Good day to you. This is Galactic on the 11th day of December, just 2 weeks until Christmas. Over here you'll see we have a new decoration. You may recognize that as a hyperbola. In this presentation I intend to cover two distinct subjects in a rather odd mixture. I have been reviewing some of my prior lectures and have found the Stanford Guide to the Santa Cruz Mountains. And in thinking about that, I thought about my friends that I've had over the years, which I associate with the Santa Cruz Mountains because that's where I lived. Now, the hyperbola is the second subject, and this shows the clear division in life. One side of my presentation today will not be considerable as a lecture, but rather as a story, which has nothing to do with this hyperbola. They literally have nothing to do with each other, showing the strangeness of what we study. And you might want to ask yourself, and you perhaps are asking yourself, or have asked yourself and have answered yourself sufficiently such that you no longer ask yourself this, why are you listening to anybody? It's just myself in this case. But why are you listening to anybody who's talking about this? Wouldn't you rather hear stories from the Santa Cruz Mountains? Well, I say no. But it is 99% of life, and this is less than 1%. So why are we studying it? It's because of the offset between the two subsystems of a human. This is binary logic, and so it's an ideal approach to the existential questions. Or questions. Some people think it's just one question, just why? Just why? Well, I agree with that. But there's a time and a place for everything. You have to divide your attention between different subjects as you proceed through life. The obvious is the stuff that you talk about when you open up a scientific discussion. I may not get around to talking about my friends from the Santa Cruz Mountains, but I did want to throw that in. Maybe as a taunt, maybe tantalizing, maybe I'm shooting myself in the foot, as they say, or just a better analogy or metaphor would be you're dribbling and you hit the basketball on your foot. You don't take a Colt 45 and point it at your foot and then look into the face of the children and go, it's like that. They're like, what? Oh, oh, oh. This is how I reacted. Well, Stanford will cure you of that partially. But the hyperbola, you can see, first of all, am I even saying it right? Aren't there 4 things there? Well, if you're clever, you'll see that there are actually 8 things there, if you don't count the numbers, which is kind of a pun. But there are also numbers. There are also 3 text boxes. 2 of them have equations, and the other one, pardon me, I'm just going to make a very quick adjustment here. I don't think you can see the entire... Is that better? I hope that helps. My goodness, it helps me. There's our... We had to call back the engineers and have them install this plate over here. You just saw it. That actually took 5 hours, but I used fast forward. So now that this giant sculpture is firmly in place over here, you know, we can now see it fully. You can see that there are actually 11 things here. 12. 13. So there are 13 things here. 14. Unless you count the vertical lines and horizontal lines differently, in which case there are 15 things here. But if you count the center, there are 16 things here. And if you count the edge, there are 17 things here. If you count the imaginary depth, then there are 18 things here. So we could start anywhere, but there are some special points here. Only, as I will come to show you again, this is kind of like my shtick, you need to be careful when you say the word point. You need to be ultimately careful. Because point might have more than one definition. Geometry is an interesting axiomatic system. And the point we do currently consider to be the axiomatic basis. It's really Theorem 0. Theorem 0 is the predecessor of your first theorem. And that's meant to encapsulate a recursion, sometimes called an infinite regression. It's a form of circular argument, but it's more like a spiral argument. You could even go further if you know anything about spirals and suggest perhaps it could be an equilateral spiral or it could be a logarithmic spiral. What you're looking at is a hyperbola. But this is a hyperbola. But then you can see that that's an incomplete statement. And now we proceed in binary fashion, which is why I'm showing this to you so that you will understand something about numbers and their value and their role both in geometry and in mathematics. Mathematics is the complicated one. It shouldn't be. Numbers are ultimately simple. It looks similar to a parabola. And what is the difference between a parabola and a hyperbola? If you look at the two top equations, which are meant to describe the dual aspect of this hyperbola, that's why there are two equations, not one. The first equation represents the green hyperbola. And now this is using the word hyperbola in a dualistic sense, which does not contradict the first definition, which is that it is one thing. Now we're saying it's two things. In a moment we'll say it's four things, but then I'll show you it's four things based on 8 things. And then I'll show you more. But it's a binary progression. This is a binary geometric object. It is a single object. And its closest relative, which is actually here, but you would have to imagine it, is what is called the unit circle, the most sacred object in geometry currently. And that could be argued because favoritism is not something we favor in science. If there's more than one aspect, you need to say so. But it's hard to say so when the thing is already just one thing. So if the thing you're describing is electromagnetism, for instance, right away you see that you have to say something else, because it's 2 words. Electromagnetism, are they related? I'm fairly certain that you are convinced, as am I, that electroforce and magnetoforce, and there's an asterisk there because the word force is not allowed by 1/2 of science. And this is an amazing split. But that is getting a little off the topic. What I wanted to point out is this is a loaded diagram. This is filled with critical information. And I've never heard it taught. I've never seen it taught. I have stated so far only statements which are already known, but did you know them? Now, so far, I haven't gotten very far, but I am tantalizing you to listen further. So what we have here is a hyperbola, and it is one thing. And as such, it is a tangent space to the circle. If you draw the circle, and one day I'll have the technology to do so, I can point though, and if you point right up this diagonal, watch the length that you can't see, it's now at the center, right? That's 0. Where the 2 red diagonals cross, that's the origin, and it's always given the numeric value 0. Nobody questions that, and that's fine. So far, so good. If you consider that the center of a circle, and just draw a new object right now, you can dilate it out from the center by increasing the radius until it stops. It will stop at 4 points simultaneously. And that word simultaneously is a loaded word now. So we're directly into the heart of quantum mechanics right now. We're looking at quantum mechanics right now. How so? Because when you dilate a circle out to touch the inner edge of the hyperbola, The hyperbola has an inner edge. It's at 1. The inner edge of the hyperbola, inside of which is no more hyperbola, that's spacetime. It's what's inside the hyperbola is spacetime. That's a true statement. So you're looking at both space and time simultaneously, and there's that word again, simultaneous. What does that mean? It means the exact same event point. Simultaneously must be defined. It can be defined in event space. And event space exists. We call it time, but time is the metric of event space. And so what you're looking at is not time, it's event space, where there can be simultaneity. Where would that occur? At the tangent points. Because that's the intersection of two domains. You can see it. The inside is the universe. You're looking at the universe inside out. From the point of view of temporal space, which I call event space, it has points. And they're exactly Euclidean points if you want to start that way. They are Euclidean points. Which is what? Null. No existence whatsoever. Not a measure of anything. An empty point. A something that has the characteristics only that which you attach to it because it is not there. So it's a relative point. So Euclid invented the relative point because it has no meaning in geometry. Well, you know that it does. You're actually looking at its meaning. So this is a critical diagram for basic understanding of numbers, because that's a number at the reference frame. The reference frame, you've heard this term, is sometimes formed with the two words opposite. You can either say reference frame, which is absolutely correct, and that's where we get the abbreviation RF from, which I adopt. They're capital letters. It stands for reference frame. But you can also say frame of reference. What does that mean exactly? 0. Numerically. It's numeric 0. You're looking at it. But is that what it is? Yes, if you're speaking numerically, that's its value. You can see, and the reason you know that is because 1 goes in 4 directions. There's +1, and then there's another +1 that's on another axis. And then there are 2 reflection numbers. So you have the same quadrangle that you do at Stanford. So therefore, Stanford is the center of the universe. And Tresidder Union, where I drank coffee, played the game of Go, which is from China and Japan, and now, of course, all the Oriental countries play Go, the same way Western countries play chess. And yes, they also play chess, and one of the reigning champions of the world is of Japanese descent, although I believe he lives in California. And he's a wonderful man, which is an amazing thing to say about chess players, because I was a tournament chess player, and I know what chess players are like. They're normal enough, but there's quite a spectrum, and Bobby Fischer certainly brought that out carefully. Well, so it's nice to meet really good young men who are good men and play chess. They don't sound like they're cranks. They sound absolutely... In fact, this is why we look up to these guys, is because they are a cut above. I mean, they can do a lot of things if they want. Usually. But the human spectrum is just magnificent, is it not? I'm telling a story because I love to tell stories, to relieve the pressure of seeing directly inside the universe to get the answers that you need for your life. And this will apply to your human equation somehow, or you wouldn't be watching. So I intend to deliver on what we both actually want, and that involves stories. So now to return to our work, in order to have balance, because to be a good scientist, as to be a good chess player, you have to be balanced. You have to be an extraordinary human being in order to live up to your responsibility. For to whom much is given, from him much is required. That's a blessing, by the way. That is, it's interpreted as kind of, oh my God, that's kind of a curse. Well, you'd better. You see the stick. No, it's a carrot. Don't you want to know that you're being approved by your teacher? Well, who is our teacher? It's the universe. And, some people go further and give it a consciousness. But it's at least the universe. That's science. So this is the basis of science. We're going back before Euclid. Euclid actually, there should be a second book written. I should write that book, actually. I will be writing that book. I just decided. It will be Euclid 2. Because Euclid obviously gave us something of extraordinarily lasting value. You know what it is? It's the number system. He gave us null in order to geometricize the concept needed in order to yield a perfect concept of distance. Science is based on one measurement alone. And this is superpositional. This is what I've been leading into. The layered concept of reality. Just because we see everything as units or quanta doesn't mean that that's the whole story. It's clear now that that is not the whole story. And it goes all the way back to the beginning of human history, when we first started using numbers. And then, from one aspect, you could say it got out of control. But look at where we're at historically. If you have a timeline of human history, including mathematics is embedded in that, if you go all the way back to Euclid, I'll put it down here. I'll put it right at the center. Say that's Euclid right there. He's the center of the hyperbolic universal space. Well, let's say he's the center. That's maybe a bit much, although that is what it is. So that's the center of the universe. Well, we'll say that that's our time reference frame, which means also it's our space reference frame. So we're going back in space-time to this moment, this directly above my fingers. The zero, which is geometric null in the Euclidean system. So we're going to say that that's true, and then see where it leads. That's Euclid. Euclid is at the center of the science universe. And now the timeline starts to go forward. The other forward. It could be either way, though, couldn't it? Not if it's plus in the upper right quadrant, which it is. So that's why we use counterclockwise instead of clockwise. Because in order to stay in the positive quadrant, you need to go up from x equals 1. So that's why we have counterclockwise. And that gives us the north-south orientation for a direct overhead view of our solar system. Therefore, the top of the world, the north as we conceive the Earth, you could look at it from above and you're looking down at the Arctic. You're not looking at the Antarctic. That's on the other side, of course. But you're looking right down through the axis of the Earth. Which way does it turn? The right way to ask that question, and I hope I've taught you to always rephrase the question before you answer it, because very often you learn something by rephrasing the question. And it could be a counter question. You rephrase it and then you wait to see how it's received. You're looking for direction, orientation. So when you are asked a question, be sure you ask a question back. I would say it's up to you whether you just ask it to yourself, in which case you may say, give me a moment to think about that. That would be polite if you think it's going to go a long time. But you actually don't want to do that ever. You have to be quick, because it shows that you know what you're talking about. So you need to answer actually economically. You just answer the question naturally. That's what science is in its communicative form. We never get bent out of shape. If we feel any emotion rising, we quench it. We do something about it because it's interfering with a logical process, which is always peaceful. It's the essence of peaceful communication. It's never supposed to get ad hominem. which is what happens when the emotions start to rise. Some questions can be better formulated than others. It's somewhat of a challenge to ask your professor to rephrase his question. You have to know what you're asking, and you maybe asked a question back that's kind of like, maybe has a note of anger in it. That's never welcome, that's never correct. Never show emotion. You've got to be a Vulcan. So, that is the universe, and we're saying that that's Euclid, and we've started time forward on it. Oh, God. Well, whichever way time is going, it only goes in one direction, right? Well, which direction? You have the same question as when you start to draw a circle. Do you start by going up and to the left, or down and to the left? Do you even start there? Well, this is symmetrical, and that's a huge term. This is completely symmetrical, but that's not a complete statement. Although it's true, it is symmetrical. So there's superposition again. You haven't said everything. Well, you can't if you're saying one thing. But you can't communicate correctly if it's 3 things, or 2 things, or 4 things, or something, and you need to say something else. Yes, it's symmetrical. How is it symmetrical? It's symmetrical, first of all, around the origin. So is a circle. So this is an inside-out circle, and the correct way to say that so that you don't sound kind of wishy-washy, inside out is a little ambiguous. You're looking at the tangent space to circular space. If you consider the circle as a unit in the plane, then it makes circular space. That's tautological. But that would be disregarding the lines. So that's superpositional. So curvature is superpositional with this grid. Curvature is superimposed onto the grid. You could say it that way, or you could say it the other way, because it's another chiral binary choice. Chiral and binary refers to linearity, and chiral refers to circularity. This, of course, is forming a binary pattern in geometric space, as well as in numeric space. But these are fundamental axiomatic and subaxiomatic insights. This is getting back to the axiomatic basis of reality. This is a very close approximation of reality. But you have to know why. It's the tangent space in circular space. And the tangent space in circular space is not a linear tangent. It's this. Now, what will blow your mind is, you now have to spin this at the speed of light. If you spin this thing, which looks kind of like a jack, well, think of it as a jack, and now it has 6 endpoints instead of 4, because you're looking down the barrel of the axis. Now spin the jack, and you will see that the 4 corners will start to rotate in the same direction. But the one at the top will seem to be going in the opposite direction linearly. That is an amazing riddle. And why would I ask you to spin it? Because every circle represents angular momentum. That's the definition of the quantum from the energic domain perspective. This is a projection. Projective geometry is the most significant aspect of geometry at high level. You have to project because you cannot see imaginary space. You are now looking at imaginary space. Where is it? It's not the whole thing. In fact, we do need to ask a question. If the entire universe is inside the hyperbola, what is the larger part of this plane? Look at above the green and below the other part of the green I keep saying parabola, it's hyperbola. They're closely related.
That's why they both end in
bola.
There's a hyperbola and there's a parabola. As you know, a parabola has a very strong linear aspect. Fire a projectile, it could be just a teeter-totter, just the astronaut steps on the teeter-totter, and the hunk of lead goes flying. Now this would be dangerous near the craft. And that would be a terrifying mishap if, he slipped with his boot and just hit the teeter-totter, but it went at a 45-degree angle, and he launched it in a parabolic. This is
the whole purpose of this metaphor.
And it struck one of the struts on the craft, and it took off sideways, and it just died on the moon. So, what is outside of the hyperbola? We know it's inside. It's the universe. By the way, what does that then make the hyperbola? Since we haven't really said much about what is this hyperbola, what is it as a surface? It is a surface, but you see it has strange edges. In fact, it's somewhat of a dicey thing to say that it has an edge at all. But if you look towards the center, you can see that it pretty much has an edge. It's just that it has 4 leak points. That's not 4 leak points. That's just 1. Because the 2 diagonal axes are meant to measure angular momentum. And those are what are spinning. But you see that the whole thing spins. Now picture it spinning so fast that it's solid. That is, that it's continuous. Well, that's a mind blower because of those 4 asymptotes that go to the diagonal infinities. Those are not closed. That's Zeno's paradox going off into the quadrantal distance. The quadrangle aspect is spatial infinity, but it's also time infinity. And that's what's going off to infinity, is space-time, because it's infinite in this diagram. It has to be infinite because there's no edge to the universe. And so the asymptotic diagonals represent the progress of space-time into infinity. But now you have to spin it because it's rotating. And when you do that, you exceed the speed of light at the asymptotic. And then you'd have to say something else. Well, where exactly in this expanding, you would have to now say sphere. This expanding sphere that goes on and on forever, that's both time and space running off to infinity together, holding hands. That's time and space running off to infinity together. Well, they can't because they're rotating. And beyond a certain limit, they would vanish. Where exactly is that on this graph? It's exactly nowhere. And that's the definition of infinity. It's exactly... Now, we don't want to say nowhere, because that has no real meaning, because that's virtually a synonym for infinity. It's the nowhere that's beyond infinity, or that it is infinity, or just before infinity. But what do all these infinities have in common? They're imaginary. We can't imagine it. And it's kind of oxymoronic in a way. But we say now, logically, very logically, it's going to imaginary space. And we call it that, although we haven't done anything until we define what we mean by imaginary. And that has never been done. I'm going to show you how to solve that paradox. The first thing you need to know is that most paradoxes, I believe now, are dual. So what you're looking for, if you're clever, is the other paradox that matches your paradox. And that is a paradoxical undertaking, because you don't even know what it is that's paradoxical. So now you're looking for another aspect of what baffles you. That gives you orientation. What is it that baffles us about infinity? We say it in several ways. One of the most popular ways, and I would certainly be susceptible, I have said it this way, it goes on forever. What do you mean forever? Time out of mind. Out of mind. Yeah, it goes down to the meat, goes to the gristle, goes to the nerve, goes to the center of consciousness. What in the world are we even talking about? We have to answer that question, but we have to do it rationally. That's the trick. So what does it mean to be rational? It means that you're equating two quantities, but these quantities are abstract. So what you're doing is relating to things, and that's abstract. If things, what are they? Are they real things? Is there anything real here? Yes, there is, and that gives us a clue to imaginarity. It's the difference between what we can see, such that we know we're seeing it, and what we can't see, that we know is there. It's there. The James Webb Telescope has confirmed our wildest imaginations. It just seems to go on and on. That is encountering huge resistance from a modeling camp. There's a certain modeling camp that they get emotional. They get very emotional for extraordinarily good reason. It's not because they're right. It's not exactly about rightness. Although ultimately in science it has to be. But in the case of the modeling camps, they're funded. Money, as soon as money, I'm sorry, that's the end of our story there. I will not go there any longer. Because these men are making a living. You know what they're doing? They're surviving. Would you want to be told that the way that you're surviving is somehow not as glorious as you thought? I mean, they talk themselves into this. Oh no, you cannot challenge what we've already proved. That's not science when you talk like that. But that's the resistance that one encounters. It's really impersonal. And it should never be taken personally. We are out on a limb. You and I are mad scientists from their point of view. But they're very small clique. It's just they have an extremely loud bark. They're barking. They're barking mad. You can't do that in science and still stay sane. From the point of view of a rational club. Oh, we're still here watching every move you make. We watch each other in science. Well, here in this hyperbolic diagram, you are indeed looking at space-time. But what if that one were the Planck length? So now we're looking at the quantum. Does that look like the quantum? I can tell you, it exquisitely looks like the quantum. It shows all four rays of the Dirac hypercomplexity. It's actually all four rays of space-time. So this is beyond the grand unification theorem, no matter how you define that. And it does have a modern definition from a club who are funded. So you can't argue with that. If you're getting money for what you're doing, you are holy. And I mean that from the bottom of my heart. Are they right? That has very little to do with it. It's not about being right. It's about being alive. If you can make money, I don't care if you're selling skunks' assholes that are parboiled in boiling neon. If some sucker, including a cop perhaps, comes and buys your skunk's asshole on a stick and then raves about it on Times Square, You do not question that. Ever. The policeman didn't. Who are you to blow the whistle on their operation? You're essentially interfering with high enterprise. Don't. Do it. Don't ever attack these men. You leave that to me. I'll attack them. Not you. You're risking something when you do that. And so I don't ever go too far. And in fact, I've sworn off several times, it comes back. Why? Because of this. That, what you're looking at there, is the intersection of itself with me. I will explain this. I will, so that you can understand it at the cutting edge of science. Isn't that nice? I don't ask for money. So as for what anyone says about my approach, you take your fanny pack and you take it to Half Dome to the jump off. And you take your fanny pack and you toss it off in front of you and dive after it. Do not stand in my way either. Whatever you are, club, cartel, clique, next greatest thing in mathematics, stay out of my way, and I'll stay out of yours. You could capitalize on what I know. You're not smart enough. That's a challenge. I hope you are. I don't hide this from anybody, but I hope you want it. I hope you want it for the right reason. So you're looking at a tangent space to the universe. And most of what it is neither time nor space, and it's most of the space on the plane. What's above one going up is non-existent completely. It's not even part of the graph. The graph itself ends at the hyperbola. And the asymptotic diagonals are inside the universe. So they're real. So what is that diagonal? It's a dual diagonal, and they are perpendicular, aren't they? Well, you're looking at the universe and those two crossed red lines, which you could call the asymptotic lines if you're referring to the linear aspect of asymptosis. You can see there's a linear aspect to asymptosis, and there's a curvature aspect to asymptosis. That's because asymptosis, which is the hyperbolic curve itself, is the intersection of two domains. It's a force field. That was proved by Ruđer Bošković and myself. And it took both of our discoveries to make this discovery. So it's a profound insight into universal dynamics. You are looking at two intersecting forces. The red line, which is, you could say, is two lines, but it's actually one line because this is rotating. So it's the integral of the rotating red line. That also rotates the hyperbola, doesn't it? It rotates everything because the frame of reference is rotating, and that makes zero continuous. It's a continuous imaginary center, but it is continuous, and therefore it exists. But it is not linear zero unless you want it to be, because that's one of the derivatives of spherical zero. One of the derivatives of spherical zero, which is a higher order space, obviously, one of those must be linear zero. Yes, it is, but there are four of them. There are four linear zeros there. There are four linear zeros there. That's the derivative of the integral zero. So the zero is structured. Does it have an interior? No, because it doesn't exist. It's imaginary. Now you can draw a circle around that geometric center, which is imaginary. How far out does the imaginarity go? It depends on the mathematic context, and we're getting to that, but we're leaving that open for a second. When you draw the circle out to its largest radius, its circumference is 1 because it's motion, because it's angular momentum. It's the motion that makes the circle. The circle has no existence. It's equivalent to spherical 0, but the spherical 0 has a 4-component derivative, which is the geometric center in the space that you and I see. And so the radius is the inverse of tau. So the radius of this circle, we can now transform the radius, which has a value of 1 in a linear grid. The Cartesian grid shows that the radius of the circle is 1. However, we don't want 1 there because that's the incorrect metric, and you can see it's not incorrect, it's derivative. Well, that's incorrect. The derivative is not incorrect. The derivative will be correct because it's the basis of all science, is that jump from 0 to 1 on the radius. That's the metric of linear space, is 1 Planck unit. So that is a very real number, that radius. But is it 1? It can't be, because 1 is in the numerator for the radius. The radius has a numerator of 1. The anti-radius going out has the reciprocal of that radius. But that radius cannot be 1. Why? Because the surface of the circle is 1. It's the integral 1 because of angular momentum. That makes the angular momentum of that circle 1. The angular momentum component of the circumference, which is the circle, it's the surface, has a value of 1 in spherical space. I hope you're projecting. This is a sphere. You're looking at a sphere through its tangent space in circular tangency. So not only is this spinning, it's spinning in a way that we cannot see. It's spinning both vertically and horizontally simultaneously, and there's that word again, simultaneously. The red line that's the diagonal is the flight of the photon. You're looking at the flight of the photon. It's on the red line. It goes in 4 directions on this graph, but it's going in 1 direction in the universe. It's going out. So this is a diagram of the universe, which is bounded by the hyperbola. And it's also a picture of space-time according to the flight of the photon, which is on the diagonal. That's the way the photon is going. It's going out. Does it ever reach infinity? This graph says that is infinity. That is infinity. That is infinity. Can we geometricize that? You're looking at it. Can we enumerate it? Can we attach numbers to that? Can we attach a number to infinity? Yes, you can. You're looking at the answer. You're looking at the answer to the rationalization of infinity. You're looking at the quantum, you're looking at the Planck length, you're looking at space-time, and you're looking at light speed. You're looking at angular momentum, you're looking at the fundamental constant of the universe. It is the universe itself. It had to be. That's why it's uni. It's not split. But you could easily convince yourself that it is split because of that infinity, because it goes somewhere real. Yes, it does. It goes to hyperspheric space. And hyperspheric space is the analog, it's the direct equivalent of spacetime. Spacetime is hypercubic. You see it. You see this is a cubic grid. It's actually a hypercubic grid that's been projected down through two linear dimensions. But if you look at it spherically, it's in the same dimension as the sphere. That is projected down one dimension. This is a sphere projected down to a circle. You're looking at the circle. That thing you have to see, not the way you see it. You have to see it spinning. How fast is it spinning? We know the answer. It's spinning at light speed. And therefore the angular momentum is constant. The angular momentum is constant. The angular momentum of the universe is light speed. That's its angular momentum. The flight of the photon proves that, because the photon goes out on that red line. That's one red line. So you can think of this entire hyperbolic interior as being filled progressively with red, except inside the circle. The interior surface of the hyperbola is a circle, obviously. It's actually a sphere. And what you're seeing is a perfect evoluting sphere. This is the diagram of spherical expansion. And so it's accurate enough to say on a first pass evaluation, the universe is expanding. This shows the expansion of the universe. That is incorrect. That's the linear interpretation. That would lead to a direct contradiction with relativity, because the universe would spin faster and faster toward the edge. It does not do that. It's a flat spin. Just as a spiral galaxy has a flat spin, and that's the end of the dark matter controversy. Truly speaking, the dark matter hoax, but I don't blame these men. They merely pursued the linear solution. You can see from this diagram, they were doomed to failure because they can't see the rotation. That's the expansion. Rotation implies expansion. But the mind bender that just blows everyone away, it fooled everybody, including, well, really Zwicky. It even fooled my own greatest teacher, Fritz Zwicky, the greatest astrophysicist who has ever lived. Halton Arp was of his generation. Halton Arp is certainly the greatest in his category. So as usual, the beauty pageant contest has several winners, not just one. But I'm human. I do have heroes. He is a great teacher. And he was blackballed by a certain club. So I do have a certain latent animosity toward club dynamics when they're no longer human and no longer scientific. That's the key. You can't blackball Fritz Zwicky. You can't blackball Halton Arp. You can't do what you did. You did it. Well, I remember these things. Club of Rome. Every club. I don't care what club you're in. Get out. Get out of your club. Unless you're making money. This has been a public broadcast announcement requirement. I'm required to say that. I accept this restriction. I have said what I said because I'm allowed to say it under the Freedom of Speech Act. But as for calumniating your club in any way, nope. Nope, it's just one lonesome man's opinion. I don't counsel anyone to hate you. I don't think you're hateful. But I think you need to examine yourself if you're still a rational scientist and ask yourself what you're doing in your club. Why do you need this club? If you're getting money, God bless you. Go your way in peace. We are friends forever. Don't worry. I'm not attacking your club. I'm defending science. So this is the basis of all mathematics, all geometry, and all physics. This is the answer to the paradox of what is the universe. It's the answer to what is infinity. You're looking at the quantum. I need to show you the dynamics of the angular momentum to show you why light speed is constant and does not exhibit centrifugal force, but the photon itself does exhibit centrifugal force. It has energy. So you're looking at energy. It's the red line. Space is inside the parabola, but it's not the red line. It's what is not the line. And so time is imaginary for this reason. Energy is imaginary. And that's as real as it gets, darling. Energy is in imaginary space. It's not in space. It's not in space. The electron is not a spatial particle. So now we have the answer to the atomic geometry such that it can be understood. You're seeing spherical geometry in action. The interaction between anti-space and the space that we can see. And that is the universe, defined on the two-force balance centripetal-centrifugal interface. There is no such thing as any quantum anywhere. There is no quantum. That's an artifact of linear Bronze Age mathematics, because you have accepted zero and you haven't seen that when you go to circular space, you have to change the zero. And when you do that, you solve the collapse of the wave function, you solve the quantum paradox in all of its aspects, and now the children can understand it without you confusing them. And so I will continue to broadcast. Thank you for tuning in. I am working on the LaTeX document, which will be published at GitHub. The prototype will be there by Christmas. I have 2 weeks. And then you'll be able to read my paper. It will be the beginning of a series of papers, because I intend these papers to be brief and hard-hitting, irrefutable, watertight, bulletproof, shock-resistant, proof of the basis of arithmetic, mathematics, algebra, the meaning of the calculus for the very first time, and the unlocking of all the secrets of astrophysics and microphysics, so that you can understand all of it without calculus, without complex numbers, and without sine cosine. You'll be using rational whole numbers at all times with no possibility of any mathematical errors whatsoever, because I've rationalized infinity through proportionality. That's the number system you'll be learning. It's the original number system that God uses. I'll pay for that in some way, but you know I am trying to get attention. It's the number system that God imposed on his universe for us to enjoy. This is Anagalactic. Keep looking up. We're here to have fun. I address all age groups. I hide nothing. But I am a diplomatic man, and I am here for your good. I pray. I hope you're having a good time. And in heaven already. We'll be right back.